Alright, hi there. Today we're looking at polynomials, which is in your textbook 2A. Okay, before we begin, I'd just like to ask people if you've ever heard of a thing called BODMAS. BODMAS. Alright, chances are that you have. But what you may not fully know about BODMAS is what the heck this O stands for. And what that O stands for is actually order. Order. Now, I personally prefer, instead of BODMAS, I prefer BIDMAS, putting an I there, because then the I stands for index. Index, which everyone sort of knows because we understand our indices, which are the same thing as powers, or exponents, if you like. So we all know that you need to do, say, 2 to the power 3. You do that bit before you do times 5 or your subtraction or something like that. So you always do the index first. It's index, or it's also known as order. So order is an important concept we're going to be looking at when we're thinking about polynomials. So we already kind of know that what it really means is this index thing here. That's the order. So with polynomials, we describe polynomials as having an order. So polynomials we'll write as polynomial and its with respect to x. So a polynomial is a type of function. You see it's written in the same way as a function will be, but we've represented a polynomial with a big P here. Now, the easiest polynomial you can get is just a polynomial that's a constant. So here let's choose one. Let's make an easy one. Make it 2. The polynomial with respect to x is 2. So it's like saying the function is 2. So y equals 2. Now you'll know that this is kind of like there's a silent x to the power 0 hanging around here. Because hopefully you remember from your index laws that anything to the power 0, x to the power 0, is equal to 1. In other words, 2 times x to the power 0 just equals 2. So here we're looking at the order, and we can tell the order is 0 because that's what the power of x is. Our next polynomial that we shall write will be a polynomial, so polynomial with respect to x, and I'll write a polynomial of order 1. Might look something like this. 3x plus 2. Okay, so here you just write it as 3x plus 2, but really it's 3 times x to the power of 1 plus 2. So you notice here the order is 1. Alright, now let's have a look at a polynomial of order, or of degree. So at this point I'd like to just say that order is the same thing. Another word that gets used is degree. So you say a polynomial of degree. It's the same thing as saying a polynomial of order. So polynomial now of degree 2 or of order 2. Let's make one up. Let's just say a fifth x squared plus 3x plus 2. So even though it contains this x to the power 1 term, the biggest, highest order term in this polynomial is 2. So the order here is 2. Now, you can start to see the pattern here if I did another polynomial. Let's do the final one, polynomial with respect to x. Let's just make something up. Let's say 12 x to the power 3 plus some other lower order parts or terms, x plus 2. So now this has an order of 3. And we can go higher and higher and so on and so forth, getting larger and larger order. Now, the last thing you need to know about polynomials is that if you want to find the value of polynomials, it's just like finding the value of a function. Put some sort of value in for x. So let's say this one, let's find the value of this polynomial when x is minus 2, just for fun. So the value of the polynomial when x is minus 2, if we just put a minus 2 in for all of the x's, minus 2 to the power 3 plus a fifth of x, minus 2 squared plus 3 times minus 2 plus 2. And because I'm lazy, at this point I'm just going to use the CAS calculator. So I'm going to grab a calculator page. I'm going to define my polynomial. Yep.
Food's ready.
Sweet, thanks. There's my housemate telling me dinner's ready. Polynomial of x is equal to, let's type this out, 12 times x to the power of 3, make sure I go down again, plus control x over 5, oops, that's actually x squared over 5, oh. Plus 3 x. Hopefully I've not stuffed that up. And now finding it when x is minus 2. Let's throw in minus 2. So now and there we go. It's negative 496 over 5. And if you want to know what that is as a fraction, use these squiggly lines here, negative 99.2. And there you go. That is everything you need to know about polynomials for 2A.